Good morning one and all. Today we'll discuss about microscopy. We all know that microscope is used to view or observe the objects or specimens that are too small to be seen with just the human eye. So microscopy is a technical field that involves the use of microscopical components such as microscopes or microscope objectives to obtain greater detail of examined samples. So, in definition, a microscope is a high precision optical instrument that uses a lens or a combination of lenses to produce highly magnified images of small specimens or objects, especially when they are too small to be seen with the naked eye. A light source is used to make it easier to see the objective matter. Before moving towards the exact or the designing of the microscope, let us know what are the principle of the microscope and what is magnification and resolving power. So coming to the principle of microscopy is used to get a magnified image in which the structures may be resolved which could not be resolved with the help of an unaided eye. Magnification, it is the ratio of the size of an object seen under the microscope to the actual size observed with unaided eye. The total magnification of microscope is calculated by multiplying the magnifying power of the objective lenses by that of eyepiece. Resolving power is the ability to differentiate between two close objectives as separate. The resolving power of human eye is 0.25 mm. The light microscope can separate the dots that are 2.5 micrometers apart. The electron microscope can separate the dots that are 0.5 nanometers apart. What is the limit of resolution? It is the minimum distance between 2 points to identify them separately. It is calculated by Abbe equation. It is the resolving power is equal to the wavelength of light in nanometers by 2 into numerical aperture of objective lenses. Working distance. It is the distance between the objective of the objective and the objective slide. The working distance decreases with increasing magnification. What is numerical aperture? The numerical aperture of a lens is the ratio of the diameter of the lens to its focal length. The numerical aperture can be decreased by decreasing the amount of light that passes through the lens. These are the various types of or the techniques used to image an image using the microscope. Example the first one is optical microscopy, which uses the light rays for the formation of the image, and confocal microscopy uses the coherent light sources, that is the laser, for the formation of the image. The next one is transmission electron microscopy, which uses electrons. Similarly, the scanning electron microscopy also uses the electrons for the formation of the image. And the last one is atomic force and the scanning tunneling microscopies, which uses molecular mechanical probes which for the formation of the image. So this is a brief history about the microscope. The first and the simple microscope is the compound microscope. This is a common type of microscope, and the high power microscope with the magnification power from 40x to the 1000x. Compound refers to the fact that in order to enlarge an image, a single light path passes through a series of lenses in a line where each lens magnifies the image over the previous one. In a standard compound microscope, it has two lenses. One is an objective lens and the other one is eyepiece lens. The objective lens is closer to the objective or the specimen. Similarly, the eyepiece lens is closer to the observer's eye. It uses a light to illuminate the specimen. The objective lens usually consists of 3 or 4 lenses. The most used light method is trans-illumination. At 400 resolution or magnification power, detail can be seen at the cellular level of biological specimens. Applications of the compound microscope are to observe the cells and microscope in both medical and science fields. This is an image of a anatomy of a microscope, which contains the objective lens, a head, ocular lens or all the eyepiece lens, diopter adjustment, nose piece to adjust the resolution, mechanical stage to hold the sample, condenser, illumination, brightness adjustment, base, light switch, fine adjustment, coarse adjustment and the stage controller. Let's discuss about the objective lenses. One of the most important parts of a compound microscope are the objective lenses. A standard microscope has 3, 4 or 5 objective lenses that range in the power from 4x to 100x. Our objectives may vary in power from 1x to 160x in compound microscopes, but the most common power range is 4x to 100x. Most common compound microscopes have 3 or 4 objectives, usually of 4x, 100x, 40x and 100x, which revolve on a nose piece to give different magnifying powers. Numerical aperture. The numerical aperture of a microscope objective is a measure of its ability to gather light. The more light, the better the resolution of the lens. The nuclear aperture will be marked on the objective, and the typical numerical aperture for the following are as follows. Ocular lens or the eyepiece. The eyepiece consists of a series of lenses mounted in a tube at the upper end of the microscope. Its basic function is to look at the focused, magnified image projected by the objective lens and magnify that image a second time before your eye looks at the image of the specimen. The eyepieces are usually 10x but also comes in 5x, 12.5x, 15x and 20x. The x refers to the amount of magnification that this lens adds as a multiplier to the magnification of the objective. For specific or the special applications, eyepieces can have scales, pointers, crosshairs, markers on them. The eye point in the location is the location of the eye from the eyepiece, which allows for the best possible view of the image. Other parts are the diopter adjustment, which is usually means to change focus on one eyepiece so as to correct for any difference in the vision between two eyes. Body or the tube. The body tube connects the eyepiece to the objective lenses. The arm connects the body tube to the base of the microscope. The next one is for the adjustment of the brightness. So coarse adjustment brings a specimen into general focus. Fine adjustment tunes the focus and increases the detail of the specimen. Nose piece, a rotating turret that houses the objective lenses. The viewer spins the nose piece to select different objective lenses, specimen or site. The scissors. The specimen is the object being examined. Most specimens are mounted on slides, flat, rectangular or thin glass. The stage is where the slide is placed, and the stage clips are to hold the slide in place. Stage height adjustment is to know these are the knobs which move the stage left and right or up and down. Aperture. This is a hole in the middle of the stage which allows the light from the illuminator to reach the specimen. There are on and off switches for the to operate the illumination to off or illuminator to off or on. Illumination, that is a light source to project the light over the specimen. The other one is diaphragm, which adjusts the amount of light that reaches the specimen. And the other one is condenser, which gathers and focuses the light from the illuminator onto the specimen being viewed. Base. This a base supports the microscope, and it's where the illuminator is located. Thank you.